Well, hello. So in this video, we're going to take a look at monopoly, which is really exciting because it's the first imperfectly competitive market that we've gotten to look at in this class. It's also exciting because all of the perfect competition stuff we've learned is cool and useful, but it's really more theoretical, whereas there are actually monopoly markets in the real world. So I've given you some examples actually right below me of images of monopolies that are past and present, right? De Beers, the diamond company, used to be a monopoly. They're not so much anymore. Typically local utilities like Ameren or Missouri American Water or Cleed Gas, those are often, also utilities. Those are also often monopolies as well, or the Postal Service or Standard Oil and things like that. Now, a couple of things to know about monopoly before we actually draw some graphs. The first is that because the firm is the only firm in the market, the firm graph is the same as the market graph. So you only have to draw one for every single time, as opposed to two, which you have to draw for perfect competition. You have to do the firm and the market graph. The second thing to know about monopoly graphs is that because the whole market is the firm graph, that they have to just take the downward sloping demand curve that we got used to. So they're going to have the downward sloping demand curve, and that's going to have a really important effect. Ooh, I don't know what that is. That's my updating. And that effect is that the monopolist has to reduce its price if it wants to sell additional units. The monopolist is what we call a price maker. They're still limited by the demand for their product, though. So in order to sell more units, they have to lower the price. And that's actually going to cause there to be a wedge between the marginal revenue and the demand curves. Now, the real learning here is actually that the price will no longer be the same as the marginal revenue. The additional revenue they get from selling an additional unit seems a little strange, but it won't be the same as the price. So in order to show that to you, I'm going to suggest that you actually take the next page where it's a big blank sheet of paper, and towards the bottom, you can go ahead and fill this out with me. Imagine that you have a quantity of a product, and we'll just say imagine that you have like a Wash U water bottle, which is sold by a monopolist like, Washington University. Get rid of this screen here for us. Oh my goodness. And so here's this is an interesting graphic that I encourage you to, pull up the slideshows and take a look at. It's all about how AT&T went from being a monopoly to back to being a monopoly again. It's pretty cool. And this is the one about Standard Oil. It's kind of a flow chart. It's kind of neat how they were broken up and then they've come back again. But anyways, this is where we really are at. So what we're going to think about is imagine a company where they sell water bottles, and they can charge the price that's essentially set by the demand for their product. And if they charged $10, they wouldn't sell any. They'd sell 0 units of product. And we know that, oops, that's supposed to be a times sign. We know that quantity times price equals total revenue, so they wouldn't have any total revenue. Now, if we lower the price to 9, they'll sell 1 unit. And so you'd sell 1 water bottle if you were Washington University, and you'd get $9 of total revenue. You lower the price to 8, you sell 2, you get 16. Now, this should look somewhat familiar because we actually did this back when we looked at elasticity. We did this idea of if the price goes lower, right, then essentially you sell more units, and it told us stuff about the elasticity. And so we used this same data set for that. But we're going to go ahead and fill out these here, 25, 24, 21, 16, 9, and 0. And so this is actually telling us, if you lower the price to 0, 10 people will walk in and get a free water bottle, but you won't get any total revenue. Now, what we want to look at is notice the marginal revenue. Remember, marginal revenue is the change in total revenue generated from selling an additional unit of a product. So we would say there isn't one for the 0th unit because there's no change. But between 0 and 9, well, that's 9. 9 to 16 is 7, 5, 3, 1, and then -1, -3, -5, -7, and -9. And so we can see pretty clearly here that if you were just that one company that sold water bottles, right, these branded water bottles from Washington University, that the marginal revenue and the price, they aren't going to be the same values at the same quantities. So like quantity 4, the price is 6, but the marginal revenue is only 3 for that unit. And the only one where it's equal is the very first one. Now, the explanation is pretty straightforward for why this happens. It's that when they go to lower the price, they lower the price from 10 to 9. Well, they don't go from a 0th unit. There isn't a 0th unit. But when they go from 9 to 8, they actually have to lower the price of the first water bottle that they sold. Like they sold both of these 2 water bottles for $8. So, and when they do that, right, they lower the price. That means they don't get the full $8 from selling the second water bottle. And why did they not get the full $8? Well, they got 8 from that transaction, but in order to get that 8, they actually had to give up $1 on the previous water bottle that they used to sell for 9, and now they're selling for 8. So that's why the marginal revenue was only 7 from the second water bottle. So the revenue generated by that second water bottle isn't 8, it's 7. And that's because, again, they had to lower the price on the previous units. We could do that again in here when they go from 8 to 7, right? They had to actually cut the price by $1 on the first and by the second one compared to where they were. So in order to go from 2 water bottles to 3 water bottles, they got 7 from the third water bottle, but they also had to give up $2 of the revenue from cutting the price on the first and the second. And so they got 7 minus the 2 they had to give up. So their revenue generated from the third water bottle is only $5. Now, at a certain point, right, the price effect of lowering the price begins to outweigh the fact that they sell additional units every time. And that's called the quantity effect. And so we'd say that the price effect starts to really take effect. And actually, they have negative marginal revenue from these units way down here. Now, this is an important difference, right? Notice that the marginal revenue and the price are not going to be the same. And the demand curve is actually going to tell us the price. The demand curve is going to tell us the price. So that's by way of saying, right, that each additional unit reduces marginal revenue and drives a wedge between the marginal revenue and the demand curves. Now, the monopolist is still going to produce where MR equals MC, and their price is going to be on the demand curve, but the quantity, they're going to use that MR equals MC. So they're kind of going to use the MR curve to tell them where to produce, the quantity to produce, and they're going to use the demand curve to tell them the price to charge. Now, there's a difference between 2 types of monopolies, and in the next video, I'll actually explain the difference in a little bit more detail. But suffice it to say that for our first one, we're just going to pretend that it's like a bicycle shop in a small town, and they're the only business that sells this product in town. So it's a monopoly, but we call it an artificial monopoly. And the answer, the distinction, will become clearer later. So our first one we're going to draw is an artificial in profit. Now, don't be scared by this picture below. I'm going to show you how we're going to get to that picture. It's actually pretty easy. So we're going to have an axis, right? Price and quantity. Make sure we label P and Q. And then the first thing we're going to draw is a downward sloping demand curve. And I'm going to encourage you when you do this to put demand equals the price, because the demand curve is going to tell the monopolist the price they can charge. Now at the top, we're going to start with the top connected here, and then we're going to come down because it's going to be like this, right? Instead of being together, it's going to be spread apart. So we're going to start at the top and come down. We're going to label that one marginal revenue. Now, it's okay if you stop before you get to the x-axis, that's fine, but marginal revenue does go negative, and we saw that with our data set earlier. So we've got this kind of throwdown, right? We're throwing down demand and marginal revenue, and they're only the same at the very first unit of production. But after that, they split apart. Now, from here on out, it's pretty much drawing what we drew with perfect competition. You're going to draw marginal cost and average total cost. And so we go down and back up again, and that's marginal cost. And that's the supply curve for the firm. We remember that from the last topic. Now, this is an artificial monopoly in profit. And we know from the last section that that means the price is going to be bigger than the ATC at MR equals MC. And so let's start by identifying where is this monopolist going to produce? Well, they're going to produce where MR equals MC. That's pretty easy to find right here. So this is the quantity that the monopolist produces at, right? But where do they price? They don't price here. They don't do that at there. Remember, they price on the demand curve. So we're going to go up, and we put a dot here, and we go over, and we say that's the price that the monopolist charges. Now, here's where we're going to draw our ATC. The price is going to be above the ATC at that quantity. So you can put your ATC anywhere you like, as long as it hits its minimum at that marginal cost and starts to come back up again. So we're going to do like right here, boom, hit, and then it's going to come right back up again, ATC. Now, where we're going to compare in order to find the profit rectangle is exactly the same as we did in perfect competition. You compare price and ATC. So we go down from the price to the ATC. And notice that it's not at the minimum of ATC because that's where the marginal cost curve is. It's just right here. And then we're going to go over. And so that is our profit rectangle. Okay. Now, that's the artificial monopoly in profit. Now we're going to take a look at what it would look like in a loss. And it's going to look pretty similar. We're going to start with the same way, price and quantity. I'll go ahead and advance our slides here. Demand, which equals the price. downward sloping, really steep marginal revenue there. And then marginal cost, down and up. That was not very much of a down, was it? And that's the supply curve for this firm. We know that they produce where MR equals MC, so Q star, and they're going to price up here on the demand curve, P star. But now, in a loss, we know that price is less than ATC at MR equals MC. And so we're going to need to put our ATC curve somewhere up here. Down, hit its minimum, and then come back up again. So notice all we really did between the differences, we just showed the ATC in a different spot. Now, we're going to go up from the price up there to the ATC because we compare these two values. Remember, you're comparing price and ATC. So what's the price to the ATC? And the ATC value is higher than the price. And so that tells us that we have a loss. Okay, so that's our get a little bit bigger here, all the way over there. That's our loss rectangle. And now we're going to look at it and see what it looks like in what we call fair return or break even. This is sometimes called normal profit, right? And now this one, it's just going to be like a tangent line if you look there. So this is almost the easiest one. Now, one thing to notice is that there is no long run with a monopoly because, right, there isn't a firms entering and exiting. That doesn't happen because it's a monopoly. There's really high barriers to entry and exit. Marginal cost, which is the supply curve. And now again, remember, MR equals MC, that's the quantity. And again, if you do these step by step in the same order every time, you'll get used to it with your hand. And your hand will almost be like muscle memory. Now we do the price on the demand curve. Really common mistake is for students to do the price down here. You're not going to make that mistake though. You're not silly. You're not going to do that. Now, we know that in break even, the price is equal to the ATC at MR equals MC. They're breaking even. They're earning, ooh, excuse me, my nose is tickly. They're breaking even, so they're earning what we call normal profit. So we're going to come down, just touch, and then keep coming down, hit the minimum, and then come back up again. Now, that looks a little wonky, I know, but you just do your best. And if you don't quite get it, just make your dot bigger, okay? And we don't have a rectangle because there isn't a profit rectangle or a loss rectangle. So that gets you the intro to the idea of drawing monopolies and understanding some of the basics of them. I'll see you next time.